6th grade. We're going to continue our lesson today on velocity and acceleration and how the two relate, but also how they relate back to our speed and when we figured out how to calculate speed. Has any of you been able to figure out how fast you run yet? That'd be an interesting thing to see if you go out and measure out a certain distance, time yourself running as fast as you can, and then stop the time once you get to the finish line, and then you guys know how to find speed, that you take your distance and divide it by the time that it took you to get there. And if you want to know it in like miles per hour, you can always go to Google and you can type in like meters per second or feet per second and type in converter to miles per hour, and it comes up. It's very simple, but then you can actually see how fast you run. You probably think you run a lot faster than you really do. And then I'm curious, were any of you able to figure out how fast Usain Bolt's run was? Leave a comment for me if you were able to figure that out, or also figure out how fast you run in miles per hour. So let's go over again what velocity is. Velocity, again, is the same thing as speed, except it's in a particular direction. So here it is again. Velocity again refers to the distance an object moves over a certain amount of time. That's the same definition for speed, where we take how long something took to go a certain distance, except for velocity, it's in that certain direction. So velocity again refers to both the speed and the direction of that moving object. All right, so let's look at this. I have 4 different answers here. I have 50 meters per second, 45 kilometers per hour west, 1.5 meters per second down, and 25 miles per hour. Of these 4, which ones are telling me simply speed, and which ones are telling me velocity? All right, here's your answers. How did you do? We have 50 meters per second, this is speed, and this 25 miles per hour is the speed, simply because it's telling me the speed. What were the key words in these 2 that made it velocity? That's right, we have west, which is a direction, and we have down, which is also direction. So remember what velocity is. It's how fast something moves over a certain distance in a specific direction. In this case, it was west or down. So now let's talk about acceleration, because velocity and acceleration work together. Acceleration is a change in velocity. Remember, velocity is going a certain distance over a certain time in a certain direction, okay? So the change in velocity during a certain period of time. So the faster the velocity changes, the greater the acceleration. Now, usually we say that an object accelerates when it does what? When it speeds up or when it slows down. However, if we're talking about this in science terms, acceleration occurs whenever an object does these 3 things. Acceleration occurs whenever an object speeds up. So think about this: if I'm driving in a car and I hit the gas pedal, I'm speeding up. I'm accelerating to go down the road. Acceleration also occurs when we slow down. Now, sometimes we call this deceleration, but if we're talking in scientific language, negative acceleration is the same thing as slowing down or deceleration. So it's a type of acceleration. So if I hit the brakes, I'm obviously slowing down, so that's a type of acceleration. Also, the third type of acceleration is when something changes direction. If I'm going in a straight line and then curving around, that's also a type of velocity. Now, if I am looking at this roller coaster right here, a roller coaster is a great example of velocity. Why would a roller coaster be a great example of velocity? Yeah, think about that. I remember all of us going to SeaWorld, and for those of you that were tall enough at the time to ride the roller coasters, we were able to get on those roller coasters, and the first thing we do when we sit down on it is it starts to go up the hill. Now, moving in a straight line, but we are going in what direction? Up. That's right. Once you get to the top of that hill and all the momentum's carrying it over, we've changed direction again. We're starting to move down, but we're accelerating, right? We're speeding up. Okay. So we are speeding up. We're obviously slowing down as we go higher. It kind of slows down, but also the brakes so that we don't go crashing at the end of the ride. So it slows down, and it, thank goodness, changes direction all over the place, which makes roller coasters so much fun. Now, most people like having cars that can accelerate quickly. How many of you like getting in a car that will go fast? For those of you that went on my field trip last year for STEM, and we got to see some of these fast cars at the auction, I love sitting in a car, and I love getting on things that ride and take off super, super fast. We want cars to go faster in shorter amounts of time. We think of cars that are going faster, like if you hear this car goes 60 miles per hour in 2.8 seconds. People want faster cars, and they want them to get to a certain speed in a short amount of time. But what is actually the most important acceleration in a car? That's right, how fast it can stop. We want to make sure that our cars can stop, so negative acceleration or braking is actually the best part of a car. Good tires and brakes, they help us decelerate or negative acceleration in a safe amount of time and distance, right? We want to make sure that as we're braking, we're all good. Now, in order for acceleration to occur, there needs to be a force. Now, what is the definition of force? Force is a push or a pull that has to be applied to an object. So if I want to make a wagon move, I have to do what? I have to either push it or I have to pull it. If you want to make it turn, you have to do what? You have to apply a force to the handle. And if I want to make it stop, you have to also push or pull it to stop. Person is pushing the car. In order to get that car to accelerate or gain speed, a force had to be applied, and that was that person pushing. And to get it to stop, you can see him up in this corner. He actually had to pull it. So again, in order to make something move or put something in motion, a force, which is a push or a pull, needs to be applied in order to get that object in motion. But what would happen if I had this same scenario, but the person was standing on ice? So I have this guy here who is now going to pull a recycling bin up his icy driveway, and what's happening? Obviously, this force that he is applying to pull this garbage can up the driveway is not working. Even the push is not working. Why? Obviously, yes, because there's ice on the driveway. Poor guy. So what force is this, or what is stopping him from actually doing what he needs to do? So let's go back to the hamster in the wagon. If I gave a wagon a push down a hill, or just pushed it even on a flat slope, if I did absolutely nothing to a moving wagon, once it started moving, it's eventually going to stop, and that's because of a force called friction. Friction is working against the wagon moving. Friction is a force that keeps objects from moving against other objects. Now, if I don't have a lot of friction, something like this could happen where we will slip, or the guy trying to pull the recycling bin up his icy driveway, it's going to be very difficult for you to stand, and there is less friction, which means you're going to slide very easily over whatever surface you're on. However, on the other hand, if you have too much friction, like not enough water on a slip and slide, you're going to have something like this poor kid right here. You get stuck there. Now let's think about this. What would we rather have, more friction or less friction? All right, so let's review our two terms for today, velocity and acceleration. Again, velocity refers to the distance that an object travels over a certain amount of time, but what's the key words? In a certain direction. That's right. So again, I can still measure the speed of something, but if it's changing direction in that time, then I need to understand that that's velocity. Then I have acceleration, and that's the change in velocity during a period of time. And there's three ways that acceleration occur. One way is if something speeds up. The second way is if something slows down. And the third way is if something changes direction. What I need you to do now is you are going to look at the notes, my journal notes. If you brought your journal home and you did this for the first set of journal notes, I need you to copy those into your journal. Otherwise, print them off if you can, or just know that they're there for reference. There's the journal notes for velocity and acceleration. And then I need you to click on the Google Doc, the button on today's lesson, and complete that form using the terms that we have learned since last week in the correct manner. Love you guys. I'll see you tomorrow.